All right, so this is this 2014 seating chart problem. So let's look at this. It says a student in a school is represented by the following class. You have a student where the class knows how to get the student's name and get the number of absences that they've had. You then have a seating chart class. And so you're going to have a 2D array of seats. Now, just think about a normal classroom. It's basically a 2D array. If you went into it, you've got all your desks lined up in rows and columns. So you got this seating chart constructor that passes in a list of students. So you're going to do, now this isn't a pure 2D array. This is a 2D array combined with some ArrayList stuff. So again, here's your student, and you can get the name and get the number of absences of that student. And we're going to have a list of students being passed in with the number of rows and columns. So you can read through this. I guess I will. It says creates a seating chart with the given number of rows and columns from the students in the student list. Empty seats in the seating chart are represented by null. So the rows are greater than 0, columns are greater than 0, and row times columns must be greater than the list. Okay. So again, here's your list. So this is a student, and it has Karen and 3 absences in it. So again, here's your array list. You know, position 0, position 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's actually 10 students. And so this is our list called roster. And it's going to be 3 rows by 4 columns. Here's row 0, row 1, row 2, column 0, column 1, column 2, and column 3. Looks like we're just going to do, row, column. So the number of, we're going to put, so wait a second, no. We're going to put them in rows first, and then go to the next column, because as we go down, look at this, we get to the end Danny, and then we want to have that null and that null. Typically the way we would do it is just kind of like this, and then we would get to here, and then we would have null and null, but they want it like that. So that's something to think about here. So we're going to do column first and then row next. Okay, so that's kind of that's an interesting look at it, a little bit more difficult. So let's write this one first. It's really not that difficult, but I set up this right here. So part A. We got to create our 2D array. So we'll just say, let's see here, we have seats right here. It's a private student seats. So we'll say seats is equal to a new student 2D array with the rows and the columns that were passed in. Okay, so this is probably a point right here. Either way, it has to be assigned. And remember, we're going to do column. Now, wait a second. We're going to do a 2D array that assigns in information from our array list, but we have to have the index of this list, okay? So we'll say int student index is equal to 0. Okay, so we're gonna have a 4. I don't know, these are We'll line everything up properly. Okay, so we'll do column major first, and then rows. So think about this real quick. So this would go here, and then here, here. So we're doing all of our columns first, but we have to add up our indexes in here. This is going to be, we need to know the size of this thing, so we have our dot size method, and we want to make sure that it's less than our student index, because again, we're going to be adding these up. If it's greater than the index, then we're putting in nulls. Yeah, I think that's how that would. All right, so we'll say int col equals 0. We'll say col is less than the columns that were passed in. Col plus plus. Then we will do int row equals 0. Row is less than the rows. Row plus plus. Okay, and as long as our student, because look at this, if we multiplied this, we've got 3 times 4 is 12, but there's only 10 in here, so we need to make sure the last 2 are blank. So as long as our student index is less than the student list dot size that was passed in, then we can say that our seats at row and the column are equal to the student list dot get, and then we've got to do this student index. Okay, we got to get the position that it's in, all right? So that's really the biggest thing you need to know. You need to get the index and then put it in the row and column, okay? So as we do this, row is 0, and then row would be 1, and then row would be 2, but column would stay 0 each time, right? So row 0, row 1, and then row 2, but column's still at 0, right? And so we put that in there. Now we do our student index plus plus. And so what this will do is this will go through up until this is 10, right? And then this will run 2 more times. So yeah, that should be good. Yeah. So then it would just add them up, and then it would leave the other ones blank right here, or null. Sorry, they'd be null. So they wouldn't add them up. So when this became, 11, sorry, let me think here. Sorry about that. So let me get back in here. So it would go 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10. And so then it would be, is 10 less than 10? No. So then it wouldn't get to these ones, and it wouldn't add anything in there because there's nothing in past index position 10. There's nothing in there. So yeah, so it just adds it up and then assigns it to the seats at the row and the column. All right, so that takes care of that. That's pretty easy. So that assigns them. So part B, write the remove absent student method, which removes students who have more than a given number of absences from the seating chart and returns the number of students that were removed. When a student is removed from the seating chart, a null is placed in the entry for that student in the array seats. For example, suppose the variable seating chart intro CS has been created such that the array seats contain the following entries, showing both students and their number of absences. After the call intro cs.remove, so anybody that has greater than 4, right? So Renee would be removed, Henry, and Fran. So you can see null, null, and null. All right, so this one's pretty easy. So let's see here. So we need to do our, and then what does it want us to return? The number. Entries without students contain null. All students. Let me go through and read this real quick. The value of the method would return 3. So you're just returning the number of students that are being removed. All right, so you want to have a count then. Int count equals 0, because that's going to be the number of students that you're going to remove, and then you're going to return count. So do your nested for loops. So it would be int row equals 0. Row is less than our seats dot length. Okay, seats is our 2D array. Row plus plus, and then int call equals 0. Call is less than seats in row 0, and we get the length. So that's the length of the number of columns in there. Okay. And then we don't want to remove rows that already have null in them. We don't want to do that again and count those up. So we want to exclude those. So we'll say if seats at row call are not equal to null, and the seats at the row call, and this is where we have to get the absences. So that's where dot get method get absence count, and we can do that because seats is a 2D array of student. So seats dot get absences, no, get absence count. So, and this, the absence count must be greater than the allowed absences that were passed in. This one right here. So if what's there, we get the absences. If it's greater than what's allowed, then we set the seats at this row and this column equal to null, and we add the count up. I think that's right. Yep, looks good. So anyway, let's go through, how they're going to grade this thing. What is this? Seating chart. Okay, did we assign seats to the number of rows and columns? Did we access all elements of the student list? No out of bounds errors. So for part A, that's something like that. Did we access all of them? No out of bounds error. Yep, looks good. Access all necessary elements of seats. No out of bounds errors. On seats array, point lost if access not column major. Okay, so they're actually going to give you, if it, like, and I caught this while reading this. Remember, it's not row major, it's column major. It's going, you know, Karen, Liz, Paul, Lester. It's doing column major. Usually we do row major, which would be, you know, this way, and then go to the next row. But if you didn't catch that, they would mark you down a point. Access all, so that's something important. Make sure you understand the difference between row major and column major. Assign a value from the student list to at least one element. So, you know, that's just part A. That's just that. Now, the big part of this is, do you remember that the student list, and then you can't just say, I mean, you can't just say student list is equal to the seats. You can't say seats at the row and column is equal to the student list. You actually have to get what index position you're in the student list. Okay? That could be a problem if you guys have issues with your array lists. You get that point wrong. All the elements are correct. Okay, and that's another point. All right, so for part B, access all elements of seats. So that's your, you know, right there. You access all elements of it. Call get absence count on student object. Point lost if null case not handled correctly. Okay, so right there, remember, you don't want to add up if the seats are already null. You want to just add them up for the ones that you're removing. Okay, so you gotta do that, or you get an error, or you don't get your point. Assign null to all elements in seats array when absence count for occupying that. Point lost if the seat array element changed in other cases. Point lost if seats. Okay, so you just got to make sure you get them all right. I mean, that's what we're doing here, and that's what our if statement's doing with this right here. And computes and returns the correct number of students removed. All right, so right there. So anyway, you can kind of see how they're combining 2D arrays and array lists. So this is kind of what's to be expected. So anyway, this video is done.